Hey guys, Miss B here. Today we're going to talk about graphing. So we have two goals. They're both in Priority Standard 2 experimentation. So first we want to make sure that we're all able to create a graph from data obtained in an experiment. And then we want to make sure that we're working towards being able to analyze that data in order to make sure it's supporting our conclusions. So the first thing I want to do is walk you guys through the parts of a graph and what each of them means. So the first thing that we'll start with here is over on the y-axis. So the y-axis is right here. And as you can notice, they have scaled it evenly. So what I mean by scale is they chose for each of these gaps, they're separated by the same amount of numbers. So in here, it's clear that they decided to count by 20s. So 0, 20, 40, 60, 80. You always want to make sure that you scale by a particular number. You also always want to make sure that you have a title. And in general, your y-axis will always be your dependent variable, what's being measured in the lab. If we move over here to our other axis, this is our x-axis. And on the scale here, you can see that sometimes it's organized in, it's like you count by numbers, just like over on the other axis, but that's not always the case. Because sometimes you'll have words on your x-axis, sometimes it will be time. In this case, it looks like they chose, intervals of 50 milliliters of water per day, but that may not always be the case. That one does not necessarily have to be scaled evenly. When you title your x-axis, remember that it's always either the independent variable or sometimes your x-axis is time. And then don't forget to title your graph. Your title should always very clearly state how the IV is affecting the DV. Okay, so we have two types of graphs that we're going to go over. The first is bar graphs. Bar graphs are typically used when you are comparing sets of data. So for example, as you can see in this example graph, people were polled on what their favorite cereal was. And so these are just different, not connected pieces of data. So you would use a bar graph to compare them. Whereas a line graph, the data is connected. That's usually because the x-axis is continuous. So in this example, data was collected over time, and that time is connected. You have 0 to 10 minutes, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. So you have continuous intervals of time. You can also have, as you'll see later, when you're doing diffusion graphs, generally you have a continuous x-axis of different concentrations of the solution. And so anytime your x-axis is continuous, it's evenly spaced, it's generally a line graph. Okay, so I just wanted to give a brief demonstration on how to accurately graph something. So let's say that we did a lab and we wanted to see how the amount of sunlight provided affected the height of sunflowers. This is an example we've used several times. So let's say I had amount of water versus height. Let's say I had 0 cups of water per day, 2 cups, 5 cups, 10 cups. And then let's say it grew 0 centimeters, 10 centimeters, 25 centimeters, 35 centimeters. So what would I first want to start with is identifying my independent variable variable and my dependent variable. So the independent variable in this lab, the thing that I changed, is the amount of water given to each plant. The dependent variable, what I measured, is the height of each plant. And so as we set up above, your IV is going to be on your x-axis. Unless you're measuring over time, then time would be on your x-axis. And your dV is going to be on your y-axis. So let's set that up. There's my y, there's my x-axis. I'm going to first title them so that I know what goes where. This will be amount of water. This will be height of plants. So my unit for the height is centimeters. My unit for the water is cups. Which really I should have picked milliliters to keep with the metric system. Sorry for that. Okay, so for amount of water, I had 0 cups, 2 cups, 5 cups, and 10 cups. For height, it looks like my lowest is 0, which we always want to start our graph at 0, and then the highest is to 35. So I'm going to choose to count by 5s. So 0, 5, 10, 15, 20, 25, 30, 35. Okay, before I move on so that I don't forget, I'm going to make sure that I title my graph. And again, I want to make sure I include how the independent variable is affecting the dependent variable. So I'm going to choose to title it how amount of water influences plant height. Okay, and so then I want to ask myself, is this a line graph or is this the bar graph? So first off, I do notice that this is not a continuous x-axis. I don't have even spacing between those numbers. This is just comparing points of data. So this would be a bar graph. So when I gave it 0 cups of water, it grew 0 centimeters. When I gave it 2 cups of water per day, it grew 10 centimeters. When I gave it 5 cups of water per day, it grew 25 centimeters. 10 cups a day, it grew 35 centimeters. Okay, and so notice I chose to do this not on graph paper. I'm going to assume that most of you at home aren't going to have access to graph paper all that often. So I do think it's important that we practice our freehand graph drawing skills, because we won't always have graph paper available to us. So this is as neat as I could get it. This is as neat as I would expect you guys to be able to do it. If your bars are a little bit wobbly, that's okay. If you have a straight edge, like a ruler at home, that's probably best to use. But as long as it's neat and clear, not using graph paper is going to be okay. All right, so let's do the first practice together. So I'm looking at bacteria growth over time, and I have we're going to be counting up to 5 days, and then the number of colonies, and that's like the number of little groups you'd see in a petri dish. So I'm first going to start with drawing my axes, and that came out a little wobbly, so I'm going to try that again. Much better. Okay, so first, what's my independent variable? What's my dependent variable? In this case, there's nothing that the researcher is really changing, so we're just keeping track of growth over time, so time is going to be our independent variable. But what we are measuring is the number of colonies. So I want to put my independent variable on the x-axis, my dependent variable on the y-axis. So let's start at day 0, day 1, 2, 3, 4, 5. And of course I want to title it time. My unit is days. And then for the y-axis, number of colonies, and there's no unit here. Okay, and so if I'm going all the way up to 405, I'm thinking the number that I could best scale by is 50 for what I could fit on my graph. So I'll go 0, let's do this, 0, 50, 100, 150, 200, 250, 300, 350, 400. Okay, and so it's nice and evenly spaced. Another tip, let's say I initially chose to count by 20s, but then I noticed it was getting too cramped. You always want to make sure that you're writing in pencil so that if it ends up being too cramped, you can very easily erase and then rescale it. Okay, so is this a line graph or is this a bar graph? I'm going to always head down to my x-axis. Is this continuous or is it over time? It's over time, so I'm going to do a line graph. So at day 0, I had 0 colonies. At day 1, I had 5 colonies. Something to note here. There's no 5 here, right? Do you guys see that I have 0 to 50? There's no 5. So you're going to do your best to estimate where the dot would go to be 5. And it'd be pretty close to 0. And then at day 2, I had 15. So again, that's pretty close down here, but a little bit higher than 5. At day 3, we had 45, so now we're actually getting up to that 50 mark. Day 4, we had 135, so we're going to have a pretty big jump up to here. And then day 5, we had 405, so we're going to be right up above that 400 mark. And again, if you have graph paper, this would be a lot easier to keep track of. But if you don't have graph paper, that's okay. We understand. So after I'm done plotting my points, I'm going to want to connect them with a line. And notice how straight my line is getting. I'm using a program that auto straightens lines for me. But for you at home, I would recommend finding something with a straight edge so that it gives you that nice crisp line. So the last thing I'm missing here is a title. We always want to make sure that we have our independent variable and our dependent variable in the title. So I think we can safely use this title right here, bacteria growth over time. And again, that ideally would be up a little bit higher so it's not running into my graph. Okay, so go ahead and practice number 2 on your own, and then your teacher can check it.